that particular code is already loaded to our console. Got it? So that's why every time we are using R. So it is very easy to operate. Okay. Now another beauty of RMD file is you can select multiple lines together. For example, I am selecting 90 into 22. I am repeating the same procedure. Go to run, select. So multiple lines will be run together. You got the result. SQRP?
Yes.
What is SQRP?
Yes.
You will get this code. So all these types of functions are known as the built-in function because its value is already stored in the function. So for good, this. Next, we are move on to the next thing, that is known how to generate a sequence. What is a sequence? It's a continuous array of numbers. Okay. To generate a sequence, there are three options you have. First one, I need to generate a sequence starting from 1 to 30. You can decide the number, whether you want to go from up to 1000, doesn't matter. So I'm just creating a sequence from 1 to 30. So easiest method is line number 26, 1 is to 30. What are these two numbers? It is a starting and ending number. Got it. Second one, 27. I am using a function. The function is SEQ. Now remember one thing, every function in R is usually a small letter case. Here you can see that EXP. I am using a small letter, log small letter. So all the functions are in R is small letter case. So SEQ stands for the sequence generating function. Inside that specify two numbers starting and ending. Now line number 28. Which function? Sequence. To generate a sequence. Then. Okay, it is not multiple of 5. Each number is divided by 5. Divide means division. Okay. So here from 2. I am using additional argument that from is 2. That is, you need to start a sequence from 1, 2, end up to 30. Each number is differs by 5. That's by equal to 5. You can run these two lines 26 and 8. You can see that first one 1 is to 30. I will generate a sequence starting from 1 to 30. Here also I am saying function SEQ from 2. Here you can see that 1 followed by 6 because 6 minus 1 is 5 because you defined it as by equal to 5.
Sir, I have basic doubt. I don't know if I am correct or not also.
No problem.
So we do have some variables like independent variables and dependent variables. For example, if you take in extension study, educational status is a independent variable. So we are going to assess that with an adoption or something, adoption to a particular technology or something. So using these two things, can this particular sequence can be measured, like to see the educational status of the participants or the samples? Can that be possible here?
Measurements?
Like I want to know the educational status of my sample.
Okay.
So I have made it as a scaling technique from 1 to 5. 1 means they are illiterate, and 5 means they have degree or above.
Yeah.
Okay. So from 1 to 5 I have made it in the Excel sheet. Like say for example 200 sample size I have made it as Excel sheet. So can that be used in the R software to run and see whether the educational status, what is the educational status of the participants?
No sir, with this you can't.
Okay.
For example, here it is a sequence function.
Okay.
Sequence means the only purpose is there should be a number should be arranged in some manner.
Okay.
So you defined it as 1 to 5 means R will generate 1, 2, 3, 4, 5.
Mm-hmm.
Actually, it is not you are looking for. You have 200 respondents. It should be marked from 1 to 5.
Now I have already marked that in Excel sheet.
Okay.
If I run it in R software, can I able to know the education status of the sample?
So you will get it how many respondent belongs to one category.
That's what I'm asking. Yeah.
That we will discuss in the later session. Okay.
But the same option is in the Excel, like random
that is
selection,
also.
right?
So any doubt in generating a sequence? No. Okay. Then we will move on to the very important session, that is variable. What is a variable? We usually call it as X, Y, Z. What is simply a variable? Or why the name variable? It varies according to what? Variable means definitely it should vary according to categories or according to the time in which you are going to study. So that's why the name variables. Now how to define a variable in R? That's important. Line number 31. I am defining a variable x. What's the sign?
Hashtag.
Less than sign.
Equal to.
It is equal sign in R. Okay, so don't confuse with this sign. There are some symbol you need to remember using an R program. This less than hyphen sign indicates the equal sign. So obviously there may be question may arise. Right? You can simply use the equal. X equal to 10. Why can't I use simply equal? Why we are using less than 10?
Above we use equal for mentioning some numbers from equal to 1 to.
So there is a confusion. See, so here you can see that here I am using equals. Now what is the purpose of that equals? So from is a function. You define it as from equal to 1. That means you need to start from 1. But here it is different. It is a variable or any name that is corresponding to x. And we assign a value for that particular variable. I am using less than hyphen sign. So R can distinguish that these two symbols are separately. As it is a programming language, you need to specify the program. That is very important. Okay. So always remember this sign. This is a equal sign. Okay. Next one. X. I am simply typing x. This one. That
Because
is-
it is a variable.
It's a variable. Why you need to type x? No, just run it. And please answer the question. First write 31 and 31. Then give me an answer.
So the exercise and the values ends.
You need to show what is x. Because you already defined in line number 31 that I need to create a variable x and its value is assigned as 10. But I don't know what is x. No, I am just asking R that what is x. Now R will show that it is 10. Why it is 10? Because we assigned it as equal to 10. No, line number 33.
X plus 8.
What is y?
X equal to y, y equal to x plus 3.
8. Okay, so what is y?
And then y.
It's another variable and we call it as? It is simply a variable. It's known as a function. Why is it a function? Because it is defined on x. Because x is a variable we already assigned. Now we are creating another variable y, but which is not at all a simple variable, it's a function because it is defined on another variable. Okay, what is the value of y then? 18, right? Because we already feed that x is a variable having the value 10. Now R can remember that x is 10. So your answer will be 8. Okay. The second thing, suppose here in line number 35, I am again write it as x equal to 5. Now I am running 33. What will be the answer? Is it 80 or 30? You didn't get my question, right? Okay, in line number 35, x equal to 5. There is no actually there. Just imagine x equal to 5. And then rerun line number 33. What is the answer? 30, why? Why it is not 18?
We assume the value of x.
Exactly. So always remember to create a variable. So once you create a same name for true variable, R will record only the latest variable. It will forget the previous value. Okay, so while creating a variable, then you have to be very careful about that because R is very case sensitive. Okay, now instead of small x, I am defining line number 35, capital X equal to 5. No, is there any problem?
It should always be in the lower case.
No, that's a function. This is a variable name, so you can give any name.
Any.
Like the capital letter, small letter, whatever maybe. But here I have changed small x to capital X. Now I am again run y equal to x plus a. What will be the answer?
It will be 13 only because it says all small. It depends on how you type it.
Yes. It's a very case sensitive. Now here you define small x equal to 10. In line number 35 you define capital X equal to 5. And you run line number 33, your answer will be 18 only. Because in the case of R, small x and capital X have different meaning. Got it? That's why we not call it as case sensitive. Next, vectors. What do you mean by vector? We usually studied in physics. Vector. No, okay. Vector. Value with the direction. We call it as the vector in physics. But in mathematics or statistics, vector is known as a what is? It's a one-dimensional array of scalars. Okay, it's not a matrix. It's a one-dimension. Matrix means it is a two-dimension. Row and column. Okay. So one-dimensional array of number is known as the vector. We need three basic functions to create a vectors in R. What are the three functions? It's listed in 38. First one, small c. Small c is a function known as the combined function. Okay. Then second one, we already studied that. A sequence to generate the sequence. So you need to use from to by. Okay. Next, RAP. It is known as the repeat function. So while using a repeat function, you have to be very careful. What is inside the repeat function? First one, the number. Second one, how many times? Okay. Now, 40. Can you please say me what is 40? Only line number 40. Just explain me what is in line number 40. That single line itself comprises what we study so.
It's also 5 is giving the what is to be printed.
Okay. First, there are many things. Okay. Starting from here, it will generate a sequence. Starting from 5, ending to 10. Each number is differenced by 5. That is the meaning of up to this. Now, that sequence is loaded to where? X. Because I am defining it as X. Then, what is the role of printf? Is it for copy? To give output. Got it? Suppose there was no print. Then, did you get the output? No. Just imagine you don't have any print function over here. Only x equal to sequence 5, 30, y equal to 5. The question is whether you will get the output. Yes, how? How will you get the output? How will you get the output? That's what I am making. A single part. Yes. Yeah. How will you get the output? Now where to get the output? Sorry. Which print bracket? Okay. Run x equal to sequence. Then in order to show the output, you need to type the text. And run it. Okay. Okay. So and line number 30, instead of print, I am just selecting only x equal to sequence and loaded to the console. Okay. Did you get the output? Did you get the output?
No.
How to get the output? You need to call x. So whenever I am calling x, R will show you output. Which means you need to write 2-line code. Now, If it is inside the print function, you don't have to call it. Whatever thing inside the print, I will directly show it to you. So that is the role of the print function. So I'm going to run line number 40. You can see that within a single code, it will show it to you. So that's the purpose of a print function. Okay. 41. 41. Yes.
Sir, can you tell
Repeat
this?
once.
Yeah, can you repeat this once again?
Okay.
Without print and with
Without print, see, look at this line. Can you see that?
Yes.
Here I didn't use any print.
Okay.
How did you get the output? When I call X, R will show you there. See, you can see that there is another line.
Yes.
X.
Hmm.
What is X? X is a variable you already saved it as.
Yes.
It's a sequence.
Sequence.
From 5 to 10,
Hmm.
sorry, 30.
Hmm.
Each number is different by 5. Now, I need to show what is X means. I need to type X, click enter. Then only R will show you the.
Type X in the console.
Yes. First you need to define X, okay?
Okay. X and then enter.
Enter. Did you get the sequence?
5, 10, 15, 20.
No.
Yes.
This one.
No.
Now the entire thing I'm just pasted into print function. Here, line number 30. Now the
Yeah.
advantage is you don't have to code X again.
Okay.
That single line itself
Okay.
gives you the output. Now tell me what is 41?
Repeat
I'm
function
using
3 and 5.
Repeat function. Now what is that 3, 5?
Three,
Yes,
six,
5 is the
five.
number which has to repeat
5 times.
Okay. Now it is stored into a variable y. I am using print function, so automatically you can see what is it. Yes sir. Sorry, 42.
They won't be anything.
42.
Type Y.
Print function. Okay. We use the combine function. Okay, see. What to combine? Y and X. Y is a sequence, it is repeating 3 5 times, and X is another sequence 5 to 30 divided by 5. Now here also it is case sensitive. Y comma X means R will first take what is Y combined with X. Reverse. X comma Y means first R will take X followed by Y.
Suppose if it is kind of like 5, 3, 10, 3, 15, 3, 23, 25, 3, 33 like that.
Repeat function.
ആദ്യം 5 പോകുന്നു പിന്നെ 5 10 15 അല്ലേ മിക്സ് ചെയ്ത് പറഞ്ഞെങ്കിൽ ഉദ്ദേശിക്കുന്നത്
No, this is then you have to do it. It won't shut. The combine function is whatever thing you have, just combine. So if you create the sequence like that, R will use that.
ഒരു കാര്യം എക്സ്പീരിയൻസ് ആകുമ്പോൾ വളരെ ക്വസ്റ്റ്യൻ വളരെ കമ്പയർ
open source and basically paid open source എല്ലാം paid ആണെങ്കിൽ നമ്മൾ ലൈസൻസ് വേർഷൻ കൊടുക്കണം അല്ലെങ്കിൽ ആർട്ടിക്കിൾ റിജക്ട് ചെയ്യും.
Second thing, എല്ലാ analysis you are facing and especially graphics. The carbon, every type of graph it's by default the graph so that's why I so far it's good. No doubts? Everything is okay, right? Moving to very interesting question, that is creating a data. So what is a data?
Print out the data.
C is a combined function. that's the data frame. So before moving to data frame, actually you need to know about the matrix. What's the matrix? It's a two-dimensional array of numbers, usually arranged in the form of the rows and columns. But there is a limitation for matrix. What's that limitation? Okay, why we are using matrix? As I told you, it is a rectangular array of numbers. What is the purpose of using matrix? Of course, it's a combination. Basically, it will easen us the calculations. So that is ultimate use of the matrix, because data should be represented in the form of a matrix. But the disadvantage is you can use only numbers in matrix. But we are dealing about behavioral science, especially social science. So we need to deal about the categorical variables. What is a categorical variable? Are they numbers? In some case, it can be numbers, right? Because categorical variables are usually divided into two. What are they? Ordinal variable and nominal variable. Ordinal variable is the ranking variable. That's order is important. That's why we need ordinal variable. Second, nominal. Because the outcome will be names. For example, color. It can be red, blue. So that's why it is known as nominal variable. The continuous scale you already know, it is a measurable parameter. But the disadvantage is you can deal matrix only for the continuous variable. But we need to deal about categorical variables also. So matrix representation won't be sufficient in order to deal about the categorical variable. For that purpose, we introduce another form of data that is known as the data frame. The advantages of data frame is which can deal both categorical as well as the continuous data. Okay. Now, line number 46. Can you please explain what is in 46?
Patient ID.
So I am creating a variable named it as patient ID. Then combine. What are the numbers? 1, 2, 3, 4. Okay. Then 47.
Age.
Another
Combine.
variable age.
Combine.
Function.
25,
The
34.
corresponding age of each patient. Then diabetes. Combine function.
Type 1, 2.
We will
Type 1.
find anything interest over here.
2 times it is done. No? Type 1, type 2, type 1, type 2.
Two different pages.
Okay, type 1 and type 2. Those are the levels of the variable diabetes. No, anything interest inside the bracket?
Accordingly to the age,
Okay, according to the age of the patient, we simply write it as what type of diabetes they have. My question is, what is the double method problem? Right? Right? The double method problem?
Particularly the calculation we have to do.
So it's also type 1, type 2. Everything has the double method problem. Right. Coming to the next variable status. It's also got double method problem.
So we need to classify or on which category these people are falling
Yeah, we need to categorize it very clearly.
based on their age.
Yes, no, based on the age, it's based on the patients.
Based on
Okay.
the patient, sorry.
But the double inverted comma is what kind of variable these two?
Patient ID would be sequential, but age would not be like that. So
No, sir, in a simple way.
Assigns.
No, in simple way, 46 and 47, what kind of variable it is?
how many patients are there?
Okay, sir, what kind of variable it is?
Independent.
Because independent. So it's a numerical variable.
Numerical.
The outcomes are only numbers.
Numbered.
So if you are representing a combined function for the continuous variable or numbering variable, you don't require a double neutral comma. Whereas the last two variables, diabetes and status, are not continuous, it's a categorical variable. To be more precise, first one, diabetes is a nominal variable. Why? Because there are two types of situations only. First one is the type 1, second one is the type 2. Then coming to status. Is it a nominal variable or ordinal variable? Why status is an ordinal variable? Because look at the outcome, it should be poor, improved, excellent, which means we need to give some ranking
Scaling.
priority. So
Mm.
that's why it goes to ordinal.
Ordinal.
So these two are basically the categorical variable, which means you need to define the outcomes as a category. So we call it as in SPSS it is a string variable. You got it? So string variable, that's why you need to define inside the double. Okay. Then 51.
ഈ ട്രൂ ഇസ് ഈക്വൽ ടു ആണെന്ന് പറഞ്ഞ ഫോൾസ് എന്ന് പറഞ്ഞ് കൊടുക്കാറുണ്ട് നമ്മൾ ഈ ഷീറ്റിലൊക്കെ അതൊക്കെ ശരിക്കും പറഞ്ഞാൽ അതൊരു ടൈപ്പ് വേരിയബിൾ അല്ലേ
Which type variable?
പക്ഷെ അപ്പൊ നമ്മളത് ഫസ്റ്റ് സൈറ്റ് റീഡ് ചെയ്യാൻ ട്രൂ ഇസ് ഈക്വൽ ടു ആണെന്നൊക്കെ
I think in the later session I will tell you about that. This key type is variable for the category. Then. So in our hand we have now 4 variables. What are the 4 variables?
Patient ID, age, type of diabetics, and statistics.
Now, with these 4 columns, or we call it as 4 variables, I need to create a data. Because this is my data set. Okay, is matrix is sufficient? Can I go for matrix?
Yes.
No. In matrix we can enter only the numbers.
Two-dimensional.
But the problem is
There are
diabetics and
words.
status are not numbers, it is category, which means you can't express this data in the form of a matrix. So we require another form that's known as the data frame. The function is data.frame. Okay. Patient data, that is the name of my data frame. Okay, it is equal to what? I am using the function data.frame. So data.frame function will gives you the data frame. Now inside that you need to define the variables. What are the variables we have? We have the patient ID, age, diabetics, and okay. Then 52. Patient ID. Now you will get your data. So please run 46 to 50.
Okay. Start with this. How to input the data from Excel. Actually, he has given a file and also given codes. These are the codes. I think we have to. But already he has given some Excel files also. From that only you were taking the current file.
data. But actually, we don't include this step, right? Because we have Excel in our hand. Usually we feed our data in Excel. Okay. But there are some situations actually you require this particular program. Okay. So that's why I'm just introducing this. Okay. In practical sense, we simply load our data into Excel and directly import it to R. So just keep this point in your mind. Okay. Now the second thing is how to identify a particular column or element from a data frame. Okay. We already created a data frame and named it as patient data. Now line number 56. Okay. 1:2 means what? Look at the bracket. It's not the usual bracket. It's a closed bracket. So each bracketing will be different meaning. Okay. Now patient data. What's patient data?
The data that has been
The data
generated.
frame you already created in R. Now, after that, I am using the closed bracket means something inside. Okay. 1:2.
ID image.
Patient
I
ID.
require the first two columns of my data frame. So that's why I am using the argument patient data 1:2. For example, if you have your own data, for example, sample data. So you have say 10 columns in your data. But for a particular analysis, I require only the 2. So you can use the function my sample data inside that 3,5 or 3:5. 3:5 means it will
Sorry,
be
earlier-
3, 4, 5.
Earlier, before running this patient data, you said about this patient ID 1, 2, 3, 4. So, if there are more than 200 patients, then should I have to write 1, 2, 3
No, that is a
till
disadvantage
200?
of data frame.
Till
You can define
200?
it as manually.
Or 1 hyphen then 200 like that? Will it take it
that
as
will
1?
generate a sequence.
Okay.
Okay. Now there are limitations of data frame. Okay.
Ah.
So that's why we are jump on to Excel in order to avoid these kind of problems. So, okay. Next 57. There are another method of picking. Instead of defining 1:2, you can also pick by the variable name. Okay. Then this one is very important using a dollar sign. So dollar sign is it's a very important and unique sign in order to identify or select a individual variable from a data frame. In previous case, you can take either individual or the group variable. But the dollar function is mainly used to pick one variable from a data frame. Okay, that's why I am using patient data dollar age. Because I need to pick only the age variable from my data. Okay. So far good up to 50. Follow it.
The square bracket is like
That is for a peculiar function, not for the open bracket. Because before the bracket you need to define which data frame you are looking for. Next one, 62. Everything we started with the summary statistics, right? What are the measures in summary statistics? Summary statistics. That's the first thing whenever we have a data in our. Okay, descriptive variable, that is the mean, median, then minimum, maximum. Okay, there. Okay, then something you want to write from this side to. Okay. Now, once you are using a summary function, that will calculate the summary statistics for your patient data. How many variables you have? 4. Patient ID, age, diabetes, and the status. Okay. Here, this minimum value. What is first key? First quartile, then median, mean, third quartile, maximum. So these are the informations you will obtain from a summary statistics. Now, what about this? No, it will be an answer for your question.
Okay.
Did you get any summary statistics for these two variables?
I got
You got it. You didn't get it.
different answer.
You got different answer.
Status excellent.
No. Did you run up to 73?
No, up to 62.
Up to 62. He has run correctly, but
Okay, up to 62.
no. Correct only you have done, but initially what you have selected matters. Have you selected from 46?
46. 46 to
62. 62. 62.
till here.
Run. Now it is coming. Now it is coming.
Yes, yes.
It's the
But
same
actually,
thing.
we need to get that kind of result. I'm coming to that. Okay. So now the problem is, for the variable diabetes and status, we couldn't get any summary statistics, right? Because it's a categorical variable. So summary statistics function won't work for it's only work for the numerical variable. Got the problem? But we can't omit these two variables, right? These are also information. And we have to go for conclusion based on this also. Okay. So we have to take care these kind of categorical variables. Okay. And that's the question. Okay. Now, what's the thing? So that's why there is another feature in R that's in line number 64. That's it. There's another function known as the factors. In factors, R is known as the nominal and variables in R. So, whenever your data set having this categorical variable, the first thing is you have to define these variables as a factor in R. Got my question? Okay. So, be very careful about categorical variable. You can't simply omit it because it also got a lot of information. So, if you have these kind of variables in your data file, first thing is convert these two variables as a factor variable. How to convert a variable into factor is in the line number 66 and 67. Identify the categorical variable. How many variables we have? 2. What are they? Diabetes and status. That is 66. Diabetes equal to factor diabetes. I am using the function factor. Inside that, each variable should be converted into factor. 67. Here also, I am using factor, but additional argument, right? Why additional argument? What kind of variable is status? Exactly, it's a ranking variable. So, it's up to you whether you want to give us an order or not. Got it? It's an ordinal variable. Okay, you have to define the order whether it should be 1, 2, 3, 4, 5 or 5, 4, 3, 2, 1. So that's why you need to give an additional argument order equal to false or true. Order equal to true means it will assign the order. Otherwise, by default, it is the order equal to true. Okay. Diabetes, any issue? No, because it's a nominal variable. It doesn't have any order. So you can simply use the factor function to convert it to the factor variable. Whereas status is an ordinal variable, which means you have to either define the order or you can simply omit. Omit in the sense the order you cannot ignore. Okay. So if you want to see there is no order, you can use it as an order equal to false, which means R won't give any order for those kind of ordinal variables. It will gives order, that is highest goes to the 5. Like yeah, but some variable we are not looking for. Okay. That's why it's up to you. Whether you want to order, give it as order equal to. Okay. So my intention is this. Define those two variables as a factor variable. Now I am creating line number 69 again data frame, right? Because two variables we changed. So you need to create the data frame again. Data frame, patient ID, age, diabetic status. Okay. Now I can run from 66 to 73. Now you can see that.
That was what you were getting.
You got the result?
Okay.
See what is changed?
Every day. Every day.
Now the categorical variable also gives you some.
I
Example,
just wanted to
diabetes
see
you
if there
have
are
two
any.
options. What are they? Type 1, type 2. Then how many patients belongs to type 1?
The data
There are
frame.
2 patients belongs to type 1, 2
Given the data.
Here.
How come? Because here the data frame, the status is given here false.
By default, true all.
How come? Okay.
By default, true all.
ഔട്ട്പുട്ട് ചെറിയ
Output is the one number. So here, excellent, improved. Now, it also goes on main. So I purposefully omit one line. That is the 71. I'm using a function known as str function. It's known as the structural function.
Structural.
That will gives you the object structure, because now you can see that in your data frame 4 variables. What are the 4 variables? Patient ID. Of course, it is a numerical variable. That's why it is NUM1234. Next one. Age is also a numerical variable having the number 25. But here, diabetes, you defined it as a factor. How many levels? What? 2 levels. They are type 1, type 2. Next, status. It is also a factor variable having 3 levels: excellent, improved, and poor. So that will gives you the structure of your data. That is the role of SPR function.
So say for example, we are writing the patient ID as respondents. Okay,
Yeah.
respondents 1, 2, 3, 4, 5 up to 100, and age. All I'm saying is not in R but in Excel.
Excellent.
And in age, we are classifying like this: random numbers, whatever the age comes, it is. So now, if we are putting that in R, can we copy that and directly paste it, or we have to from the Excel how to take those numbers to R,
Okay. Now that's the.
or should I have to type it again
No,
here?
no, next one.
Oh, sir, next one. So I'm quite advanced going on.
Now you should go.
Okay.
So after this is the basic section. Any doubts in the basic? This next section onwards, directly move on to how to import the data, install the library. So after this, I have finished the basic session. Any doubt? And we have some bright findings. Any doubts? To clarify for the basic session. As I told you, why I am starting from the basic means now you think that it cannot be useful or applicable in any situation, but when we are moving to further analysis, in some of the steps, we have the benefits of this basics. So that's why every time I started the concept with the basics.
67 and 68. If I need an online variable, what about the other 2 variables?
This is the numerical variable. There's a numbers, right? But other 2 variables are not